published a complete theory of what's called endogenous technical change, which allows us to understand the economic roots of technological progress. So Nordhaus built a model that he called DICE, Dynamic Integrated Model of Climate and the Economy, and it has three interdisciplinary parts, modules. One is the economy, another one is the carbon cycle, and the third one is the climate. In the economic model, Nordhaus builds on traditional growth theory, but it adds fossil fuel as an important good for businesses and households. They use it for their energy needs, and this gives rise to carbon dioxide, CO2 emissions. Carbon dioxide moves into the atmosphere and goes into carbon circulation among different reservoirs. That happens in the carbon cycle module. And finally, the climate module describes how the climate is affected by the greenhouse gas carbon dioxide. The climate also affects the economy by causing damages by global warming, and that's also described in the economic module. So now we have the pieces that are needed to do the analysis, and I'll show you an example of what we put to use. This is a graph that shows us what the model predicts for carbon dioxide emissions over time, under the assumption that we don't change our current climate policies. Here's another graph. That's what comes about if you do a calculation that's similar to what governments do when they do cost-benefit analysis and think about pros and cons. That leads to carbon tax, and that curbs emissions. The next one is also the same type of calculation, but where the government puts much higher weight on future generations. You see that emissions fall even more. Finally, a similar path is arrived at if you set a maximum degree of warming to 2.5 degrees. So these kinds of calculations and different generations of DICE have been key input into the IPCC report. Paul Romer, in the 1980s, puzzled over the following type of data. Here you see growth experiences of 3 countries. They're just examples, but they illustrate something important. Chad grew between 1960 and 1981 by -2% per year. Singapore grew by almost 8%, plus 8% per year. And the Philippines were like in the middle, and they actually grew like the world as a whole. So you see huge income gaps opening up over the course of only 2 decades. This has staggering consequences for human welfare, and Romer concluded that likely technological growth was behind the long-run economic growth observed in these different countries. So he asked himself, what explains this technological growth in market economies? And the crux was to understand ideas, he thought. Ideas for new technology. Where do they come from? And his vision was to build a framework where ideas give rise to new ideas, which give rise to new ideas, propelling growth over time. So, what kind of a product is an idea? He had to come up with a new way of thinking about goods and services. And I'll try to illustrate this here with a rectangle. And so he thought of normal goods from the textbooks as rival goods. Here's an example of a nice dish of Swedish meatballs. That would be a rival good. It's rival because when I eat the meatballs, nobody else can eat them. Not very deep. But here's an idea. An idea is a non-rival good. This is the Pythagorean theorem. And when I use it, and people use it all over the world at the same time, I don't prevent anyone else from using it. They can use it for free. That's a very valuable idea. But it's not the kind of ideas that markets provide. Here's another idea. What is this? This is computer code, but you can't really see that it's computer code. Why? Because it's encrypted. So there's a dimension of ideas which is that can be excludable or non-excludable. The theorem cannot be excluded, but a computer code can. And Romer realized that it's the excludable types of goods that can be provided by markets. Here's something in between, somewhat excludable. This is the recipe for the Swedish meatballs. It's in Swedish, so it's hard to understand for most of the world's population. So he focused on this part of the rectangle. Ideas are non-rival. For market production, they need to be partly excludable. Restricting access is key, but it's also tricky because restricting access means that there will be monopoly power, and we know there are problems with monopoly power. So Romer incorporated this new paradigm, this new way of thinking about goods and services into growth theory, and built a simulation model, much like Nordhaus's dice model. So these two researchers, they have asked different questions, they have worked entirely separately, but they have many things in common. One is that they build on the same growth theory framework. They also ask questions of a truly global and long-run macroeconomic nature. They don't provide definitive answers. Why? Because these answers are, the questions are huge and very difficult to answer definitively. But they offer us the methodological tools to begin finding them in the form of dynamic simulation models. They also offer us great advice in terms of thinking systematically about economic policy. So Nordhaus highlights what economists call negative spillover effects. And here the idea is that when firms and when businesses and households use fossil fuel, they pay for the production of the fuel, but not for the damages they cause when they generate emissions. So he advocates a global carbon tax, and he shows us how to compute it. Romer highlights spillover effects too, but in this case they're positive. Here the idea is when an innovator comes up with a new idea, the innovator may make some profits, but doesn't fully get the benefits from how this idea helps other innovators. So this means that you may need R&D subsidies on top of a carefully designed patent system. The impact clearly of the research of of this year's laureates has been enormous. It's had huge amounts, it led to huge amounts of subsequent research, and in the policy sphere, it's had immense practical relevance for global macroeconomic policymaking.
Thank you very much, Per, for that excellent presentation. And now we may have one of our new laureates with us on the phone line. Dr. Romer, are you there?
Yes, I am. Good morning.
Good morning. This is Jarlan Hansen, who spoke with you about half an hour ago and gave you the good news. We're having a press conference now here at the Royal Academy of Sciences, and we have a number of journalists here, and I'm sure some of them would like to ask you some questions. Yes. We have a gentleman over here who would like to start. I think he's from Swedish television. Please.
Okay.
Congratulations, Mr. Romer, for the prize.
Yes, thank you.
This is Knut Karlsson for Swedish television in Stockholm. I must ask you, you wrote a paper a couple of years ago in New York when you were very critical against your colleagues on the current state of national economics. What do you think about those thoughts today?
Well, in some sense, what both Bill Nordhaus and I have been thinking about is the process of science. It's what the Nobel Prizes recognize, many of them, several of them. And science is the most important social system humans have ever developed. But part of how science works is by criticism and challenge. There's no authority who can shut things down. There's no Supreme Court. Different individual scientists say what they think is right, and when they think their colleagues are wrong, they will say that. And so by criticizing over some dimensions where I thought there were some weaknesses, I was really just trying to do the thing that has always been part of the scientific method.
May I just ask you, is there still a fog of math, as you called it, in science?
I'm sorry, is it still? Oh, yes.
Yeah, Foggle Moth.
Yeah. This is a subtle issue because math is a language, just like, Swedish and English are languages. Math is very good for producing results and explaining results like the Pythagorean theorem that Per mentioned. So math can be used very productively in a very helpful way. But sometimes people use it in a way which creates a kind of a fog of misunderstanding. And part of what I was pushing for, and I think everyone needs to keep pushing for, is that we all try as hard as we can to communicate clearly, because this is part of what this presentation brings out, is that knowledge is valuable only if it's communicated to other people, and it won't be accurately communicated if people are vague or confusing in their communication. So is there still some fog in our science? Of course, there's fog in our communication on everything. There's always room to do better, and that's part of my job, is to help push that we all do better.
Thank you very much. Now we have a question from Associated Press.
Hello. First of all, congratulations, sir, on the prize. David Keaton from the Associated Press. Now, this prize comes at a very timely moment. The IPCC released a report today with major climate scientists saying that the world has only a dozen years to prevent global warming past 1.5 degrees, unless which could then, if it's not succeed, yield to serious risks of drought, flooding, extreme heat, and other environmental crises. To what extent can this prize highlight not just the environmental risk, but also the economic risk to the planet if the world is not able to find an effective solution to combat climate change? Thank you very much.
Yeah. So first, let me say that it's a shame that Bill isn't on the call, because he'd be best positioned to speak to this. I also want to be clear that the economics that I was struggling with about ideas this was a case where I could draw on work that Bill had done about monopolies and patents and ideas in his own PhD thesis. So there's a direct connection between my work and Bill's earlier work. I can't speak for him, but I think he would agree with me on the following point. It's entirely possible for humans to produce less carbon. There's some trade-offs, but once we start to try and reduce carbon emissions, we'll be surprised that it wasn't as hard as we anticipated. I read a little bit about the concern people had when we addressed the problem of the ozone hole caused by fluorocarbons. There were many people saying this would be enormously expensive and difficult, and then once we actually set about reducing emissions of fluorocarbons, it was a non-event. So I think the danger with the very alarmist portraits that people are giving, for which there's no basis, is that it will make people feel apathetic and hopeless. It's entirely doable for us, even now, to start bringing down the path of emissions and to protect a better future in climate. And it's entirely possible for us to have better standards of living as far into the future as we can see. So I said I was a conditional optimist. If we do the right thing, everything can keep going better, but it is time that we start doing the right thing.
Thank you very much for those thoughtful words. We have a question. The gentleman over there.
Dr. Rummen, congratulations. My name is Johan Schrick from Dagens Nyheter in Stockholm. I know that you have put forward rather controversial and bold ideas concerning how to deal with global migration. And that was some years ago. How do you look upon this issue now?
I want to borrow a phrase that's attributed to Winston Churchill. I don't know if he said it. But my suggestion for dealing with potential migration flows is the worst idea that's ever been proposed, except for all the others. The problem is that there are no perfect solutions to a problem with enormous human consequences. And what I was trying to do was encourage people to think about some possibilities that weren't perfect. There's no question they wouldn't be perfect, but they would be better than what we have now, and I think better than any of the alternatives that others have suggested. So as I think people have come to realize we don't have good alternatives, and as they realize the scale, there are hundreds of millions of people who say they want to leave the country where they were born. I think that this may be a time where we also start to think a little bit about what could we do to give people who are desperate to be safe, desperate to have a job, desperate for their children to have a future, what could we do to make it possible for them to pursue those goals, the things that we all pursue?
Thank you very much. Now, we have time for one or two more questions. Who was next? The lady over there, please.
Congratulations, I'm Sufjan Axelsson from Greenpost and Channel Radio. I ask a simple question. How you expected that you win the prize? What was your reaction when you heard this news? Thank you.
Well, I got two phone calls this morning, and I didn't answer either one because I thought it was some spam call. So I wasn't expecting the prize.
But finally, we were able to establish contact, unfortunately, for the press conference. Yes, the gentleman over there.
Anders Malmgren, Swedish TV4. Congratulations from me as well. In what way do you think the prize can contribute to focus on the climate questions?
I'm going to make a conjecture about politics, which isn't my direct area of expertise. But my sense is that optimism is part of what helps motivate people to attack a hard problem. And I think one of the problems with the current situation is that many people think that dealing with protecting the environment will be so costly and so hard that they just want to ignore the problem, they want to deny it exists, they can't deal with it. I hope the prize today could help everyone see that humans are capable of amazing accomplishments when we set about trying to do something. And if we set about making the policy changes that are required here, we can absolutely make substantial progress towards protecting the environment and do it without giving up the chance to sustain growth. So I hope that the optimism will help us shift over into taking the steps that we really need to take.
Thank you very much, Dr. Romer. And there will be more opportunities to ask Dr. Romer questions and hear his views on these important issues in December. So we look forward to meeting you in December, Dr. Romer, and